Hello everyone, welcome to the SI UK India webinar. Thank you for joining us. We are now live with Durham University. Today we have Tom, Chris and Pooja with us. They will be taking us through this webinar. We'll answer all the questions after the presentation during the Q&A session. So let's start the webinar. Over to you, Chris.
Alrighty. Can we see the slides?
Yes, we can.
Great. Amazing. Well, thank you everybody for attending this webinar session today. I'm Chris Marcotte. I'm going to talk to you about the Masters in Scientific Computing and Data Analysis, which we call MISCADA. I will refer to it as MISCADA throughout this presentation because the full name is kind of a mouthful. So first things first, we're going to meet the team. We'll talk about the course. Then I'll hand it over to Tom to talk about living in Durham before finally talking about how to apply. So first things first, Dr. Anne Reinarz is the director of the MISCADA program. Unfortunately, she couldn't be with us here today because she's ill. I am stepping in, that's me, Dr. Christopher Marcotte, as the deputy director of the MISCADA program. So if you come and join us in Durham, you will be very familiar with both of us because you will spend basically your entire first term talking to us. I also want to share with you this movie that we produced about the MISCADA program because, well, it's quite nice and it covers a lot of the essential topics. So if you'll bear with me.
MISCADA is a suite of MSc courses made by scientists to train the next generation of scientists. For this, we have leading experts from the field. We equip people with the newest kit, and we run everything in brand new facilities.
So we've got an all-new math and computer science building since recently here in Durham. There's also a new teaching and learning center. Durham's a very old, very beautiful city. It's a World Heritage Site, and the university has a collegiate system. It has a very friendly, very international community of students, and it's a very, vibrant and rich city to live in.
MISCADA consists of three pieces. We have generic methodological training, we have a specialization area, and we have professional skills training.
In the general methodological part, the students will learn how to write large-scale software for simulations, as well as work with large data sets. We've got 4 specialization areas. We've got earth and environmental sciences, financial technology, astrophysics, and computer vision and robotics. In earth sciences, we focus on the prediction and analysis of phenomena behind climate change, natural hazards, and natural resource management.
In financial technology, we focus on the mathematical principles behind financial markets and cover a range of areas, including probability theory, statistics, and mathematical modeling, to name a few.
Our astrophysics specialists try to find out why we think the universe is mostly dark matter and dark energy. They use cosmological simulations and galaxy surveys, plus they use among the best computational kit available in the UK.
Our specialists in computer vision and robotics make machines understand the environment around them, allowing robots to operate and interact seamlessly and autonomously with the world around them. For this, they rely on cutting-edge artificial intelligence and sensing technologies and build machine learning systems which both learn from and adapt to their changing environment.
There's a lot of synergies, a lot of linking between the different modules, and you actually learn to utilize what you are learning in your courses.
So after the MISCADA course, a lot of the students go on to do PhDs. It's a very research-focused MSc. A lot of them also go into companies to work in research and development in those companies. They go into finance, they go into high-performance computing, all sorts of things.
The ideal student has a background in the specialization area already. It is important to have good math understanding and good programming skills because we want our students to take the newest theoretical ideas and directly translate them into working codes in their respective application area. If you want to work on the highest level in your area, either in academia or in industry, then this is the right course for you.
Right, so two things have changed about that video. It featured Professor Tobias Finzerl, who was the previous director of the MISCADA program, and at the time, Dr. Anne Reinarz was the deputy director. Now, Anna is the director, and I am the deputy director. So, in MISCADA, the course will equip you with a solid understanding of the underlying computing and data analysis technologies and methodologies. We're really looking to empower you with skills and knowledge to do research. This has a very strong research component in the program, particularly with computing and data analysis. We really want to facilitate a deep insight into state-of-the-art applications in your respective domain. And we want to enable you to bridge this sort of ever-widening gap between application domains, big data challenges, and high-performance computing. But of course, being able to write a high-performance computing program is not enough. We need to make you aware of the societal, economical, and ethical responsibilities, opportunities, and implications of your work. So it's not enough for you to write some code. You have to understand why you're writing it and write it well enough that it's not going to harm anybody. So like the video said, we have 4 specializations. We call them streams. This is astrophysics, financial mathematics, earth and environmental sciences, and computer vision and robotics. So I'll just go through these streams briefly to give you an overview of what they cover. In astrophysics, the students will be introduced to ideas at the cutting edge of research in astrophysics and cosmology. The video mentioned dark matter and dark energy. And lectures in this stream will be presented by academics in the Institute for Computational Cosmology and the Center for Extragalactic Astronomy here in Durham. So this will cover topics like stellar structure and evolution, stellar populations, stellar dynamics, lots of stellar things, galaxy clusters, the Milky Way, and cosmology. This is a really interesting stream. So my background is actually in physics. So I have a place close to my heart for astrophysics. In the financial mathematics stream, students will be introduced to the mathematical principles behind modern financial markets. This has a very strong mathematical flavor, and it educates students who will later go on to work in typically quantitative divisions of financial technology companies. I do want to emphasize that this stream in particular requires a very strong mathematical background. It covers probability, statistics, partial differential equations, stochastic processes, a really broad set of mathematical topics with the application domain of financial mathematics. In the Earth and Environment stream, we seek to provide advanced knowledge of how to use data sets and tools to tackle cutting-edge and societally relevant problems relating to the Earth's environment, and especially the management of its scarce resources. This includes a variety of Earth and environmental data sets, specialist mathematical and software tools, and quantitative and computational analysis. So this includes spatial information systems, including GIS, which you are maybe familiar with if you're interested in this stream, and remotely sensed data. One of the professors on the stream takes the Earth and Environment students out on a trip to actually get remotely sensed data using a drone. There's both forward and inverse modeling to interpret environmental data, and quite a bit of statistical modeling. If you have something as big as the Earth, typically you don't describe each minute detail, you describe the statistical properties of that large thing. And finally, we have our newest stream. This is computer vision and robotics. In the stream, students learn how machines understand and interact with the environment and design robots to operate and interact seamlessly and, importantly, autonomously with the world around them. This includes cutting-edge artificial intelligence and sensing technologies, machine learning systems, things that learn from and adapt to a changing environment. So this includes supervised and unsupervised deep machine learning techniques, automated scene understanding from varying sensor payloads, and robotic guidance, planning, and control. So we have these 4 different streams. There are unifying aspects to the program as well. So we have in the program the professional skills module, which runs the entire year. This teaches you important skills in how you actually work with other people, really the social aspects of software and research. There are also the Core 1 and Core 2 modules. So all of the Core 1 modules are shared by all the students on MISCADA, so every stream. And the Core 2 modules are selected by students. So you'll have, several students from different streams on each one. So you'll do Core 1 in Term 1, you'll do Core 2 in Term 2, and you'll also have specialization lectures, so from your particular stream in both Term 1 and Term 2. Now, I've said a few times that MISCADA is a very research-focused program. Probably the largest research component is this project here in Term 3. This takes up the whole of Term 3, so the students are starting it just now. And it goes until the end of the summer. It's sort of the last thing you do in the program. This is a research project that you take on with a member of staff, typically in your specialization area, where you do some novel research. So in Term 1, the first term, in weeks 1 through 4, we have Introduction to Data Analysis, which is everybody, Introduction to Scientific Computing, which is everybody, as well as your specialization lectures. In week 5, you have your first professional skills workshop, collaboration. That was me. So you will see me rather early in your MISCADA journey. And then in weeks 6 through 9, we have Introduction to Machine Learning for everybody and Introduction to High Performance Computing, which is for everybody. That's my course, as well as your specialization lectures. In week 10, you'll have your second professional skills workshop, which focuses on presentation, communication, and ethics. And then that's the end of Term 1. In the second term, again, we have a 4-week block, weeks 11 through 14, where you do your Core 2 modules and specialization. In week 15, you have professional skills again. In weeks 16 through 19, you have more Core 2 modules and your specialization lectures. And then in week 20, your project starts. One of the really nice things about MISCADA is that we don't set exams. So we don't have exams where you come in and you sit down and you do an exam during the exam period for the university. Rather, everything is assessed by coursework. This means you'll have some sort of small project that you work on, and you'll hand in some documents, which is either code, often a Jupyter notebook, a report, and maybe give a presentation. So this is quite nice because it means you have more time to work on things. There's less pressure, but there's also an expectation that you'll really take the opportunity to demonstrate your mastery of the concepts. So students on MISCADA, we're really trying to get you to understand how things work and do not work. It's not about how to use some piece of software. We want you to create new methods, implement them in new software, write your own codes. It's really meant to be a starting point for further research. So our students typically go on to PhD programs or research and development divisions in companies and industry. And even some students go on to work in national labs, both in the UK and abroad. So we're really trying to give you foundational skills in research so that you can go on to do bigger and better research tasks. And with that, I think I will turn it over to Tom to talk about living in Durham.
Perfect. Thanks, Chris. That was great. So yeah, my name's Tom and I work in the marketing team here at Durham University. And I'm going to talk a little bit now about what it's like to live in Durham alongside your studies. So get the next slide, Chris.
Yes.
Thank you. So yeah, our university. So we're a world top 100 university. And like Anna said in the short film that we just showed, we're a distinctive we're a collegiate university, which makes us quite different from a lot of other universities here in the UK. We're actually England's third oldest university, and we were founded in 1832. We're an incredibly diverse place, so we've got students and staff from over 120 countries. And just like Chris said, we've got really strong kind of industrial links and excellent employability opportunities once you've finished your course. So yeah, next slide. So our location, Durham is a small city, and we're based in the northeast of England. We're incredibly easy to get around and incredibly easy to find. So we're approximately 12 minutes from Newcastle. We're about 3 hours by train from London, and now we're in 45 from Edinburgh and 2.5 hours from Manchester. So once you're based in Durham, it's incredibly easy to explore other areas of the UK, and we're really, really easy to get around. We've got a massive range of kind of cultural and sporting activities to be part of when you're here in Durham. We've got a world-class cricket stadium just 10 minutes up the road, and the city itself is full of places to kind of eat and drink, meet up with friends, and enjoy your time outside of your studies while you're here in Durham. So next slide. And our city, so not only will you get a world-class education by coming to Durham, but you'll also live in a magnificent place. So we're an incredibly safe city, but we're also beautiful and a historic place to live. So the university itself is built around a UNESCO World Heritage Site, which is focused on our castle and Norman Cathedral, which is kind of a beautiful backdrop to your studies. We're a city that's easy to get around on foot. So you can walk across Durham in about 30 minutes, and we're surrounded on all sides by countryside. So whether you're looking for kind of that buzz of city life or the kind of slower pace of the country, there's really something for everyone here in Durham. Next slide. Yeah, then we've just got a really short film just to show you what it's like to live here in Durham. Perfect. So hopefully that's given you a bit of a flavour of what it's like to live in Durham and the wider area here in Durham. So get the next slide, Chris. Yeah, so obviously a kind of big amount of your time here in Durham is going to be taken up with your studies. But as part of the university, there's so many other things that you can get involved with. The picture at the top is actually from our holy celebrations that took place over the weekend. And there's so many things that you can be doing outside of your studies to really kind of enrich your time and make it an outstanding time when you're here with us. So we've got over 200 student societies that you're able to join. Last year, we were actually voted Sports University of the Year by the Times and the Sunday Times Good University Guide. 85% of our students are involved in sport, music, theatre or volunteering. We've got 86 different music societies for you to join, so there really is something for everyone, and over 700 college sports teams across 18 different sports. So no matter what you're interested in, you'll find something to fill in your time outside of your studies. Next slide. And then in terms of support, there's so much going on to help you really kind of feel well, comfortable, and to get the most out of your experience here. So we offer advice in terms of immigration, healthcare and GP services, access to student finance. We've got an excellent student wellbeing program. We offer counselling services as well as chaplaincy and faith opportunities, and our equality, diversity and inclusion that kind of runs through everything we do. So hopefully that's given you a little bit of an overview of what it's like to live and study here in Durham. And I'll pass across, I think, to Pooja now, who's going to talk to you a little bit about the entry requirements. So thanks.
Thanks, Chris and Tom. That was really a very nice presentation. And now to move on to the steps about how to apply, I would like to introduce our entry requirements to all of you. The basic entry requirements are as follows. We require a 3 or 4 year professional bachelor's degree with 60% and above in physics, or a subject with basic physics courses, or in computer science, mathematics, earth sciences, engineering, or natural sciences with a strong quantitative element. So we basically require you to have your previous studies that align with your master's degree. For English, you need to prove your English proficiency through either IELTS, TOEFL, or there are a series of other English exams that we accept. We require IELTS 7 bands or equivalent, and there is also a requirement of minimum speaking, so which would be 6.5 in IELTS, TOEFL IBT, it is 25. On Cambridge scale, it is 176, or for Pearson Academic, it is 62. The additional requirements are programming knowledge on a graduate level in both C and Python is required. Specifically for MISCADA Financial Technology pathway, we require some undergraduate level mathematics covering linear algebra, calculus, integration, ordinary and partial differential equations, and probability theory. So I would pass on to Chris.
Thanks very much. So if you are interested in coming to join us here in Durham for the MISCADA program, there's a QR code in the slides, which will take you to the MISCADA website. You can also contact Dr. Anne Reinarz at her email, anna.k.reinarz@durham.ac.uk, or myself, christopher.marcotte, at the same. We also have a Twitter account, which is occasionally looked at. If you have any questions, so you can ask us directly, especially if you can't find the information that you need on the MISCADA website.
Thank you so much, everyone, for taking out the time and giving us this insightful presentation. Now time for Q&A session. I will help you call out the questions from the YouTube chat box. So the first question is, hello, can you provide insights into the capstone project or thesis requirement for students completing the program?
Sure. So like I said, in term 3, you will have a thesis project, which is when you are paired with a member of staff to undergo some novel research and produce some artifact and write your thesis. The thesis structure varies a bit across streams because we are interested in training you for entering a particular specialty. We are expecting you to then write to the standards of that particular specialty. So for example, in computer vision and robotics, it ends up being a bit shorter, a bit denser of a thesis because it's supposed to mimic a journal article or a conference proceedings, like a detailed conference proceedings. Whereas in like financial mathematics, you might write something a bit longer because it should be mostly text because it's math.
Okay. Are there any opportunities for students to engage in internship experiences during their studies?
So in principle, it is possible. I will, however, caution that this is a year-long program. It is quite dense. It is challenging. And even if you only have, say, 10 hours of lectures in a week, you are expected to spend an additional 20 hours doing self-study. So you won't really have a ton of time during the course of the year to actually do an internship. But for example, this is not quite an internship, but one of our really gifted students this year, as soon as she joined the program, she started talking to professors in astrophysics about joining their lab. So in parallel to the MISCADA program, she was also joining an astrophysics lab and undertaking some novel research and doing background information gathering for that. We have had a couple of students in the past who have done internships, especially if you are joining us on a visa. You have to be a bit careful because if you do not engage with the course, that violates the terms of your visa. So if you do take on an internship, you have to make sure you really prioritize the course. Otherwise, you might run into problems.
Can you provide examples of how scientific computing and data analysis are applied in earth and environmental sciences?
So, for example, one of the professors in earth and environmental sciences works on inverse scattering problems for geography. So, for example, how they actually find deposits of oil in the earth is they send sound waves effectively through the mantle, and they scatter off of pockets of different material in particular ways. And then we observe those sound waves somewhere else where they've been scattered to. And this is a rather large data problem, right? You're sending sound waves from one point, you're gathering it at a bunch of other points. You are then trying to reconstruct what happened in the interior. So this is a big data problem. It's a big high-performance computing problem. It's a big modeling problem as well. So that's a particular example, inverse problems in earth and environmental sciences.
What specific skills and techniques are taught in the course financial mathematics and how they relate to scientific computing and data analysis?
So in the financial mathematics stream, you really learn about the statistical approaches to financial technology. So for example, modeling market dynamics over long timescales. It's modeled as a stochastic process. Understanding that in detail is a high-performance computing problem because there's actually quite a bit happening behind the scenes in a market, even if your signal is rather low dimensional. I've forgotten the other half of the question.
And how do they relate to scientific computing and data analysis?
Well, hopefully the data analysis part is obvious, right? We record financial signals. That's a lot of data. It can be really astounding amounts of data. And you do various processing on it. In terms of scientific computing, this is maybe an abuse of the term scientific. This is sort of economic computing in a sense. You are trying to understand the signals and the underlying mechanisms through computational models. In that sense, it's scientific because we have a model of how it's supposed to, we have an expectation which is informed by a model about how the dynamics change. But in principle, it's the same sort of thing.
What are the eligibility criteria and application for the scholarship available for this course?
I would jump on to answer that question. The eligibility criteria is, as I mentioned, we require a 3-year or 4-year bachelor's degree from India with a minimum of 60% and above. And for English proficiency, the minimum IELTS score is the IELTS requirement is a minimum 7 bands, and there is also a requirement of speaking module. The students have to secure a minimum of 6.5 in IELTS and the equivalent of it in other exams. So this is about eligibility, about scholarships for September 2024. Specifically for students who come from India, we have international student scholarships available, which would be a £5,000 discount from their tuition fees.
Okay, so I have tried to cover all the questions from the YouTube chat box. Thank you for answering all the questions so well. Do you want to share any final words?
No, I guess just to say thank you for joining. And any other questions, please head over to our website and follow the links through to MISCADA.
Thank you so much, everyone, for your valuable time. All the audience, if you have any further questions, please feel free to contact the SI UK India office. For more update, do follow us on our social media handles. Bye bye. Take care.
Thank you.
Thank you.
Bye.
Bye.
Bye bye.